Capturing and converting all the sunlight falling on Earth into energy is a theoretical concept and not practically achievable due to various limitations, including technological challenges, environmental impacts, and the massive scale of such an endeavor. However, let's explore this concept for the sake of understanding. Sunlight reaching Earth. The total solar energy that reaches Earth's upper atmosphere is approximately 1.74 by 1017 watts, also known as the solar constant. This is the amount of energy that would be captured if Earth were a perfect sphere without any atmosphere or reflective surfaces. Energy conversion efficiency. In reality, no solar energy conversion technology can achieve 100% efficiency in capturing and converting sunlight into usable energy. The most efficient solar panels available today have an efficiency of around 22 to 23%. This means that only a fraction of the sunlight that hits the panels can be converted into electricity. Land and environmental considerations. To capture all the sunlight falling on Earth, an enormous amount of land area would be required, leading to environmental and ecological challenges. Additionally, there would be issues related to the displacement of ecosystems, land use conflicts, and more. Energy consumption. Global energy consumption is measured in terms of terawatt-hours. The world's total electricity consumption is in the range of tens of thousands of terawatt-hours per year. Calculations. Let's assume we have 100% efficient solar panels, although this is not possible, and calculate how many days of energy consumption could be fulfilled by capturing all sunlight. Total solar energy, 1.74 by 10 to the power of 17 watts. Assuming 22% efficiency, 1.74 by 10 to the power of 17 0.22 equals 3.828 by 10 to the power of 16 watts. Converting to TWh, 1 TWh equals 3.6 by 10 to the power of 12 watt-hours. 3.828 by 10 to the power of 16, 3.6 by 10 to the power of 12, equals 10,633.3 TWh. Comparing to global electricity consumption, in TWh. Let's say global consumption is around 25,000 TWh per year. Number of days of global consumption. 10,633.3, 25,000 equals 0.425 days. So, even in this highly optimistic scenario, the sunlight falling on Earth could only theoretically provide around 0.425 days of global energy consumption using 100% efficient solar panels. Keep in mind that this is a simplified calculation and doesn't account for the many real-world challenges and limitations. In practice, energy generation from solar sources must consider various factors, including technology efficiency, land availability, environmental impacts, storage solutions, and the need for diverse energy sources to meet global demand sustainably. Subscribe to Basics In and like my video. Share this video with your friends and family.